In this video, I'm going to go over how to do conversions between the mass of an entire compound to the mass of the individual elements within that compound. We're going to take advantage of the fact that we have our mole to gram conversions that we can get off the periodic table, as well as we have mole to mole conversions built into our chemical formulas. So the first problem I'm going to do as an example is go for grams of calcium phosphate, 2 grams of calcium. Then we'll go to phosphorus and oxygen, just so you see it 3 times and how it's set up and done. This process is going to be done just for the same, in the same way for most all of the compounds that you would encounter. So we'll start off by the amount given. So this is how we start off all of our conversions. So we got 3.81 grams of calcium phosphate. The unit of grams for us in chemistry is useful for measuring things out, but in terms of conversions, it's not a great unit. So we get our first conversion is to get this grams of calcium phosphate into moles. So we look at the periodic table, we add up the mass of our calcium phosphate, and we see that is going to be a mass of 310.18 grams of calcium phosphate per 1 mole of calcium phosphate. Now, the reason why I'm putting the mass on the bottom is so that our units cancel out. And now we're in the unit of moles, which for us in chemistry is our primary way of converting between different substances within problems. Our next conversion is going to use the chemical formula and the subscripts within that chemical formula as our conversion. So if I have 1 mole of that compound, 1 mole of calcium phosphate, in that compound, I would have 3 moles of calcium, because it takes 3 atoms of calcium or 3 moles of calcium to make 1 mole of calcium phosphate. Our last step would then be to convert that into our grams. And we have, again, our periodic table. We can look up and say 1 mole of calcium is going to equal 40.08 grams of calcium. And we're done with that conversion. All we have to do now is calculate it out. 3.81. Rounded to the correct number of significant digits, which would be 3. This has 3 significant digits. 1.48. Now in your calculator, you're actually going to get 1.4769, but we're dropping that 69, and that's going to round that 7 up to 8. So let's see how we do it with our phosphorus and the oxygen. Again, we start off with the amount that we're given. If you're given grams, you need to convert that to moles. We can now convert to moles of the individual phosphorus. So 1 mole of the compound is going to give us 2 moles of the phosphorus. That's because we have outside of the parentheses here that 2. That distributes through, and we have 2 phosphorus atoms in this entire compound. And finally, we look at the periodic table, and we see that our mass of phosphorus is 30.97. Oops. Follow the units. 1 mole of phosphorus is 30.97 grams of phosphorus. And again, we just go ahead and plug that into our calculators. So 3.1, we get 0.7608 on our calculators. but we only need 3 significant digits. Or if you are doing it in scientific notation, 7.61 times 10 to the negative first grams of phosphorus. We'll go ahead and do the oxygen so you see how it's done. 3.18 grams of calcium phosphate. Convert your grams to moles, always the first step. One mole of that compound, calcium phosphate, is going to be 8 moles of oxygen, because in our formula we've got the phosphate, the oxygens inside the parentheses. There are 4 oxygens as part of phosphate, multiplying it by 2 because we have the 2 outside the parentheses. Last but not least, we get our grams. 16.00 grams of oxygen is 1 mole of oxygen. 16. And we get 1.572. 3 significant digits leaves us with 1.57 grams of oxygen. And if we wanted to double check that, we could simply add these values together, keeping in mind that we rounded a little bit, but when I do that, I get 3.813, and that matches what we had at the beginning. So these masses, when we do these calculations, to find the individual masses of each element, should add up to be the same mass of the sample that we had to begin with.